Welcome to the panel, everybody. Hopefully you all brought questions that you desperately need to get answered. I am going to ask the person closest to me to introduce themselves, the company, and the responsibility, and we'll go down the line this way.
Green is on.
Green is on.
Hi, I'm Ian Elliott. I work for Google, work on Android and all kinds of things in Android space.
Hi, I'm Henrik from Autodesk. I'm a software architect in our graphics platform group. So we do shared graphics technology for a lot of our products at Autodesk.
I'm Tom Olson. I work at ARM in the media software group, and I chair the Vulkan working group.
Hi, I'm Ralph Potter. I work for Samsung, where I'm a principal representative for Khronos, which is mostly the Vulkan working group. So yeah, I care about mobile developers, mobile GPUs, Android, that sort of thing.
I'm Karen Ghavam, CEO, Engineering Director at LunarG, and lots of Vulkan ecosystem tools.
I'm Eric Werness from NVIDIA. I'm a system software engineer doing driver work on OpenGL and Vulkan.
All right, I prepared some questions, but I want to make sure, does anyone have anything they want to ask? Any burning questions that anybody has off the top of their head? All right, then it's me then. So starting from this way, moving that way. If I'm an app developer, should I be using subpasses in my app?
I remember somebody at Google a long time ago looked at that and determined no, but that was based on what they were trying to do with Angle. So I don't know generally.
So it depends how old the device you want to work on, and it depends what you need to do with it. So if you need to use things like pixel local storage on older devices, well, not pixel local storage, but if you need to use subpass dependencies in order to get low bandwidth, you don't have a choice. First of all, if you're on desktop, this is all irrelevant, right? This is only important if you're running on mobile devices that are tiled, where subpass dependencies can produce huge wins in terms of memory bandwidth. And then the question about older devices is relevant because going forward, I believe I can say, I'm a little nervous, I don't want to speak for everybody, but our expectation is that all mobile devices will support dynamic rendering well going forward. And so you can plan for the day when you don't need the subpasses anymore. And if you're only targeting recent devices, I think you can probably stop using them, if not now, real soon. I hope, I'm interested to hear the feedback I'm going to get from some of the people in the mobile space, but
I don't have feedback. It was a question. I'm just not familiar. It was a question. I'm just not familiar with the advantages, say, of dynamic render passes versus using the sub or the render pass.
Well, I mean, using dynamic render passes is nice because some sort of gnarly objects that you have to use subpass. Basically, rendering gets much easier. It's cleaner, nicer. You don't want to use subpasses if you don't need them, because dynamic rendering is just a prettier paradigm.
I'll mention that at least some of the people I know who've used dynamic rendering as it first came out have run into bugs simply because applications test things or use usage patterns that Vulkan CTS doesn't all capture. So expect it to get better and improve as the drivers get better.
So I guess I'm gonna maybe I'm rephrasing Tom's version, but if you're on mobile and you care about the widest range of devices and you want the best performance, then right now, tough. You're going to have to live with it. I do expect dynamic rendering to be on new devices. I mean, we shipped it 2 years ago on at least some devices, and local read will get you the rest of the way there for your subpass behavior. But if you care about everything on mobile, then right now it's a little bit too early to just say, no, I'm going to give up the performance.
Yeah, so in the future, when everybody supports this dynamic on
mobile. Is there an advantage if you've already made a pipeline that supports subpasses to then ditch that?
I believe with the local read extension that we just released, your shaders should still be compatible. So you're still getting the kind of on tile behavior. But you should be able to just reuse your shaders, I believe. He says a little bit fast and loose.
I'm pretty sure that it's not the case that you can use them without modification, completely the same. But the changes are kind of structured and rote. I'm pretty sure that Tobias Hector's blog about dynamic rendering local read goes into that to some extent. I'm kind of speaking at the limits of my knowledge now, but so I think you need to make changes, but I think there is a migration path which is reasonable.
All right, do we have any more questions from the room before I lob another fastball?
Hi, I was just wondering if you could speak to the apparent explosion of shader languages that we have been exposed to so far in this past couple of days. Like, I mean, not just slang, but also GLSLFX over at Pixar, and then I know I've already forgot like the other 5 or 6 that we've known. So I saw it, but I was wondering if you just kind of speak to that.
So one thing I'll speak to is in one way, I mean, on the one hand, it's scary, but for me, but on the other hand, it's kind of, I would have to say the system is working. And one of the motivations of defining Vulkan in terms of an intermediate language was specifically to enable 1,000 flowers to bloom in terms of how you generate that spirivy. It is, I mean, we recognize there's an ecosystem problem that you've got to maintain a pipeline of products and you don't want to become dependent on a tool that isn't maintained, you know, a code generation path that isn't maintained. That's a serious problem, but it's kind of the price we're paying for getting rid of the dependence on, I mean, the kind of problem we had with OpenGL, if you remember, every GPU vendor had their own GLSL compiler, and they all accepted slightly different languages, and it was nasty. And so, so it's a good problem to have. It's kind of represents the maturing of this, you know, this decision we made early that we wanted to base the API entirely on an intermediate language and not have high-level language dependencies in it.
Yeah, so I mean, the shading language question is one of the biggest one for us. You know, if you saw my presentation earlier, we need to support, you know, all platforms basically, you know, Windows, Mac, Linux, iOS, Android, and also the browser. So right now, how do we manage, you know, HLSL, GLSL, Wixel, metal shading in language? So we're quite excited about something like slang, and, you know, could there be potential to have, you know, one high-level shading language that, you know, is able to not just be the lowest common denominator, but that kind of expose at least a big enough feature set of each platform that, you know, we can use it for production purposes. So definitely one of the top of mind questions that we are asking ourselves from Autodesk.
And it's also the case that a lot of these shading languages are kind of cousins of one another. I know with the ray tracing subgroup, there was someone who was asking for example code, and I sent them slang code from one of our public repositories. Even though most of the people who were interested had never seen slang before, people could still kind of figure out what was going on with the spurvy would be coming out the back end based on the language.
One thing that strikes me about the languages we've seen is they're tackling this problem of ISVs, companies wanting to target multiple platforms, and so they need something that they can transpile across to Metal and still hit Vulkan and still hit DX. And so it's really cool to see all these new languages. I think there's going to be some challenges in terms of like, what is the plan for how you produce stable things that people can build tool chains on top of? But I'm really happy to see new things coming given that, I mean, Tom alluded to earlier, like the state of HLSL and GLSL for Khronos is really difficult right now. And so seeing other things filling that space is positive for me.
So when I talked about, just kind of continuing my earlier thought, I talked about keeps me awake at night. You know, Helmut wants to teach Vulkan at university level, and the question is going to be, what should my students write their shaders in? Well, if the tool chain is, you know, like look at your watch and look at what's out there, and you know, and the tools are different every week. How do you? Well, it's the stability question. We need an answer to that, and I'm not sure what the answer is. And Tess will be talking, but yeah, we have to find a balance. I think right now, because HLSL was stagnant for a long time, of course, now they've made some moves, and GLSL has been stagnant for a very long time. And by the way, I have to say, Vulkan is still completely dependent on GLSL and will be for a very long time. We write the conformance test in it, and it's very low level. It's very transparent mapping to SPIR-V, so it's great for us when we need to write tests for a new extension. We're not going to get away from that. It's never going to go to HLSL as far as I can see. Sorry, that was a digression. But I think we're kind of seeing a reaction to that, the fact that we were stuck in the mud for a while from a language point of view. And all of a sudden, a bunch of stuff is happening. And I think space will get explored rapidly. Hopefully, it'll stabilize a little bit after a while. But I do think the ecosystem needs to stabilize on one or a small number of tool chains. They're going to have to be open source, partly but for insurance, right? I said you can't afford to base your tool chain on a tool that somebody else supports. It's closed source, and if they stop supporting it, you're completely screwed. It's going to have to be open source, so you have at least some fallback if the maintainer goes away. But we really need more than that. We need kind of an industry commitment to say this tool is going to be maintained by a large enough critical mass that, you know, your bus factor is not 5 or something like that.
One follow-up question.
Oh, hold up. Make sure.
One follow-up question to that multiple languages is, meaning what's the story from Khronos standpoint of view with respect to extensions? Meaning we need to probably cook up extensions on GLSL, HL, or maybe Microsoft needs to do it on HLSL, and someone needs to do it on SPIR-V, and someone else need to do it on some other Khronos language. To me, at least, it feels like maybe implementations might not share the burden, but at least from a Khronos extension working group level, it seems like a duplication of effort with respect to, I need to do this extension or implement this extension on GLSL, HLSL, and various other languages that are out there. And there are misses also, like for example, cooperative metrics is an extension which has an extension in SPIR-V and GLSL and HLSL, and it's missing on certain Khronos-driven languages itself, like example OpenCL. So I want to also understand the extension story a little bit better from a language standpoint of view.
We so should have brought Alan Baker or somebody. So, I mean, as you say, when we write an extension, somebody writes an extension for Vulkan that has a shading language component that manifests typically as a SPIR-V extension. And then if you want to access that from a shading language, you've got to find some way to do it. In GLSL, we have cheated. There is an inline SPIR-V extension, so we can add a path for you to generate to access SPIR-V extension from GLSL without changing the compiler, without having to do a lot of work. It's fairly trivial. Microsoft is unlikely to support that, as far as I know, although they've been actually very cooperative about letting us do stuff we need to do. But generally within, kind of ring fenced so that it doesn't affect non-Vulkan applications. Yeah, I mean, that is, you're pointing to the inefficiency, and yes, that is a thing that bothers me, the fact that you have to do a lot of things twice. And that, you know, I wish we could have one language, but on the other hand, the fact that we can have multiple languages is a strength. I just don't know what to do with that. I don't have, in other words, I've talked for 3 minutes and I have nothing to tell you that's useful.
There were a lot of hopes that the shading language will consolidate around one language, which is HLSL, with the DXC compiler. And the question for entertainment is this experiment can now be considered a failure? And if yes or no, what are the reasons of what happened?
So if I understand correctly, you're wondering about what's gone on with HLSL, and in particular, I'll speak up a little bit because a different part of Google, Stadia, was working with Microsoft and doing DXC, and then Stadia got canceled. So now what? Is that kind of where you're coming from? Yeah. So one of the things I'll mention that I've heard quite a bit from the folks who worked on that is that there are a lot of games that's their shader language. And so if we want them on Vulkan, we have to support HLSL, right? And so they would argue quite strongly that we need to be able to support HLSL, and that DXC is a great way of doing it because Microsoft's willing to work with us. But now then there's the resource problem, right? And that's one of the things that keeps Tom up at night. I can let him speak from that side.
First thing I'm actually gonna do is out you. Christoph there is the guy who was in the OpenJLES and Vulkan working groups early and was the most savagely vigorous proponent of doing an intermediate language, and is largely responsible for the creation of Spear, I think, at least in terms of saying, this must be done, this must be done, this must be done. So, and I want to thank you for that because it's one of the best decisions we ever made. I say we made, it's one of the best decisions you've ever shoved down our throats. So a number of issues with moving entirely to HLSL. One is when we are developing new extensions, we need to be able to develop conformance tests internally under NDA in private because Khronos rules require us to do that, which means that we'd have to fork HLSL and maintain it internally and do all of our conformance test development on a fork, which is a pain and an expense. That's one problem. There is the problem that HLSL is moving forward. You know, now there's HLSL 2, and its mapping to SpearV is much more abstract. I said GLSL has a very transparent mapping to SpearV. That's really nice for the kind of work we do when we're developing new stuff. And we wouldn't be able to do that. So we got a lot of pushback from conformance test writers if we said, oh, you're going to have to write all the conformance stuff in HLSL now. It's a bunch of small technical annoyances.
I don't want this to be a question with a definitive answer, but what would cause, trigger, make you want to have a Vulkan 2.0 release?
I have the same question.
I've been a part of some internal Google discussions where people have talked about it, but it's more from the context of we did 1.0, then it's like, oh, well, let's fix this, let's add this, and so forth. And now in some cases, as some people have said already, there's multiple ways to do the same thing. Maybe it was you who said that earlier today, right? There's more than one way of doing something. And yet we still have a few things that are still too hard, right? So my personal philosophy would be, if we were to fix all of those problems and come up with, here's the nice new easy way of doing everything, well, then you could create a 2.0 that's just that and layer everything else on top of it. So you still have 1.0, but you have a very clear, here's everybody, here's what you want to do. But then as people then start, all kinds of tangents with 2.0 and, it'll take us forever to get that, everybody use that and so forth. So I would focus on, let's fix the problems that we think we ought to do, and then we can decide what to do.
So I've heard a few people ask about 2.0, mainly for the reasons of, we've got a lot of history. We made some decisions in the 1.0 days that we've come to realize.
Regret is the word you're looking for.
Well, we had some opinions in the 1.0 days and things didn't turn out the way we thought they would. Having said that, Vulkan these days is huge and it covers a lot of markets and a lot of problem areas. And part of my take is also in the 1.0 days, we said we were going to cut out some features because we thought they were mistakes in older APIs. And then we had to add them back in. And I have a worry that if we started on a cleaned up 2.0, we would end up going down the same path where we would discover that all those niche use cases that we thought were mistakes that we didn't need are just going to come back again.
Yeah, and it seems
Sorry.
Let's go to Eric first.
Cough, cough, transform feedback. Well, sorry, was somebody else in there?
you good.
Okay. Is this working? Okay, yeah, it is working. I mean, I can see a case for a 2.0 now, just in the sense of there's clearly stuff that we think of as deprecated that we don't recommend people use. So I worry not so much what would trigger it as how would we manage it so that it doesn't break the ecosystem. And, people do this occasionally. It's always expensive. And we don't have a lot of money and nobody has a lot of money to spend on stuff that doesn't add value. So maybe that's a way of saying what it's going to take is Vulkan has to get big enough and heavy enough that it's about to fall over. And that's what'll motivate it. Sort of what happened to OpenGL.
Right. And then in OpenGL, there was the whole attempt to core versus compatibility and that kind of deprecation. That was not all that successful, I would say. But yeah, I think it's kind of the same thing for me is there are these corners of Vulkan where it's like, oh, we did this. Oh, no, we need to add that. We need to add this. And now there's like updating a descriptor. I don't think I could even name all the ways to update a descriptor right now. And that's a pretty fundamental thing. And so, you could definitely see where after we add 2 or 3 more of these in the next few months or whatever it's going to take, that we might decide it's too many and need to go back and say, hold on.
So it seems a lot of the discussion is about how you've added so many ways to do the same thing. But the real reason to move to 2.0 is if you identify something that must change, it's fundamentally broken and it will break compatibility. Because as soon as you get to a next major release, you can no longer have to require the backwards compatibility. I don't think it's just a bloating issue. It's when do you find something that's broken and you need to fix it and it's going to break compatibility?
Yeah, and I hope we never have to do that. But stepping in part because I'm going to go look back at Christoph, who begged us earlier, and somebody mentioned, and I forget who, so I apologize, but somebody mentioned yesterday, what if we could create a specification that was based on a profile so that I don't have to look at all the things I don't care about. Here's the extensions, the features, the limits, et cetera, that I want to use. Could I take a profile and create a Vulkan spec that just gives me those things that I care about? So, Christoph, something to solve.
Good. People are listening to profile.
Well, I mean, that means you need a way in a profile to remove core features, which right now we don't have, do we?
Everybody's looking at you, Chris.
Well, you have something because you have a profile for Molten VK. So how do you express the fact that certain features aren't present?
An extension that can remove other things, yeah.
Yeah, the reason this is humor is because extensions are by definition cannot remove stuff. So,
That's what the portability subset is.
okay, yeah,
It's saying, hey, I don't support these things.
right.
Says don't use them.
Yeah.
But it is a good point that profiles kind of narrow things, but they don't remove anything. But
Tim, can you hold the camera over?
All right, I have a controversial question, I guess. So as Vulkan as matures, its adaptability is increasing, and you guys talked about value and all that. What is your take on a reference implementation of the spec? So that would, this is kind of, it came up during lunch, so I just wanted to hear from the panel what your thoughts are. That might solve some of your deprecation problems, right? You know, you could go back to saying, oh, there is a reference, go back to the software fallback or something like that. But what are your thoughts?
Somebody just has to pay for it.
Where does it find your value matrix, I guess?
Right now, you know, of the $1.25 million a year that Khronos has to spend on this, and that number's not going up very fast or very soon. We go through regular exercises. Marty leads it in his capacity as project manager, of looking at all of the things we could spend money on, typically by hiring contractors or by doing an RFQ. And that one has that one ever been on the list? I kind of feel like maybe it has, no?
I don't think you even know how to scope it. It's too big to put into this RFP process. And
When you think about maintaining it, because every new extension that comes out has to be supported immediately. Yeah, so it is not something that we have been able to convince ourselves we would remotely be able to pay for, and I don't think we understand the value. And I know you and I have talked a little bit, and I want to understand better. And we had that conversation earlier. Yeah, I really want to understand better how it would be used, who would use it, what would they use it for. Actually, we can. Okay, let's do it.
Yeah, I can add a little bit on that. So, I mean, a lot of our products today, their primary platform is Windows. They are on DX. And for DX, you have the Warp software fallback, and that is reliable enough. So if you don't have a GPU in your machine, or you're running through a cloud instance or over some sort of remote desktop that, doesn't support, full GPU acceleration, it actually works, and they can rely on that being accurate and give you the exact rendering of the certain line style or some feature that they have very specific requirements. It needs to render correctly. So for those products to be able to use Vulkan on Windows, that's an absolute requirement. So we need something like that, or else these products will remain on DX. So it's a very important use case for our products. And I mean, it could be beneficial for some internal work as well, regression testing, having server farms where you don't necessarily have. So it won't be to do regression tests on drivers and things like that, obviously, but for software features in our application, we could use that and be able to run on software instances.
Yeah, I was going to mention there are two software implementations I'm aware of. One of them is Swift Shader, the other is Lava Pipe, and I don't know if there are others, but those are the two I'm aware of. Swift Shader was done by a Google engineer, now a former Google engineer, right? He did a lot of great things, and then he went to go work for one of the other hardware vendor companies, and that's a problem, right? So it's open source, people can add to it, but are they adding to it? So that's the maintenance comment. But also, it's a software implementation, but is it the official reference implementation?
That's what I want to address the problem there.
So that was kind of the observation I was going to make. I can see the value in a spec conformant software implementation that people can use in a headless server or whatever. And I understand why the software version, the reference version exists for the other API. We have a spec to do the thing that the reference implementation does in some sense. Like that's our ground truth on how things are supposed to behave. It's hard for me to see the value to Khronos we have a limited budget. We spend most of it on conformance tests already. Where we would find the engineering and the money to build a reference implementation, I have no idea.
Another thing, I mean, think about some of the problems you'd have to solve. A reference implementation would have to expose some set of memory heaps with some set of properties, some set of queues with some set of properties. And every implementation out there right now, I'm sorry to say, is somewhat different to extremely different in those respects. And so how would you even say this is a reference if, it exposes a certain set of heaps and a hardware implementation exposes a different set? Is the hardware implementation wrong? How would you handle things like that in a true reference? I'm not sure.
I don't have the answers, but the same. So if you listen to the talk, what Charles said, right? I mean, like everybody here had the same problem, right? You write your code, you pray that the validation layers is going to help you out, and then you never know what will happen if there is a driver update. You will be dead in the water. It's like just productivity loss, right? You can't do anything there. You're stuck. You give your code to somebody else, it doesn't work. Different hardwares. You have, students jumping in now. So who bring in diverse hardware? So I don't think we have to think about it where do we really want to hedge everything on a driver version and hope that it's going to be stable every time? I still think there is value. Even if it's limited support to say, it doesn't do everything that the hardware would do, but it needs to at least clear show what the API can do, at least generate some pixels and show something. At least keep going on that effort.
Well, so is it sufficient then if supposing we had a full-time Swift shader maintainer or team, and they had a budget and they were stable and they were well connected, they would be well connected to the working group. Would that be enough? Because that's different from a reference. But
I think that would be a start. We could go.
Okay, you could use
Right.
that would solve your problem to some extent.
Exactly.
Okay, that's very valuable for me to understand, because creating a reference is, raises all these other questions. But creating a good, solid software implementation is a much more tractable thing from my point of view.
Yeah, and as long as it's open and we can rely on it being continuously developed, or if someone drops the ball, other can come in and participate. Yeah, I think that would be sufficient for our use case at least.
I am flashing back because I'm also on the Khronos board. I'm flashing back. I'm pretty sure that some of the other Khronos APIs have actually spent Khronos budget to create references. They were much smaller APIs. Vulkan has a 4,000 page spec, but I think some of the much more embedded focused APIs have actually done this. So it's not an unthinkable thing. It really comes down, well, like I say, it's always about money in the end. As Ralph said, we spend 2/3 of our budget on, and we have projects in mind, in flight, to do much more in the validation area. We've just let out a contract to improve that documentation, the docs.vulkan.org. That's a project that money is going into. So we, carefully prioritize and do everything. The cost of, like, if it was really one super hot engineer who was maintaining Swift Shader all the time, that gives me a back of the envelope idea of what it costs to do it. So, No, Karen is disagreeing with this. Karen knows more about managing engineers than I do. She has more in her little finger than I do in my whole head. But right, I mean, one would not be good because of the bus factor. It would have to be a project.
The problem is if you just have one person, when that one person leaves,
Right. So it can't really be that way. But in terms of how many hours of engineering time, say you need to split that one person across 4 people plus management over and context switch overhead, ballpark, it's still whatever it is.
yeah, I'm just not convinced it's just one engineer. But anyways,
Even with the hot engineer, Swift Shader wasn't fully compliant.
Yeah.
It wasn't keeping up with the extensions. And,
Yeah.
the organizational and
Yeah, even with one engineer, a very good engineer, it wasn't keeping up. And there's so much coming out of the working group that to keep up and to be meaningful and to be reference, it does take a team. It takes a team with different strengths. And then you have the whole, software development pipeline behind it. And it's tempting, anytime you get a really sharp person, getting the ball down the 10-yard line, you go, well, it's only 10 more yards. Last red zone defense is tough, and it's no easier in software development.
I'll just add quickly, the Swift Shader wasn't just a team of one, but at the end it was a team of 2, and one went one way and one went another way. So the bus factor is still a factor.
Right. So I guess I'm going to expose some of our clean laundry. Dirty laundry is another matter, but some of our clean laundry, I said when I gave my talk that we have a fairly formal development process for new extensions, which requires somebody who wants to add an extension to do a number of things. And so in principle, I'm about to get bricks thrown at me by Khronos members in the room, big bricks. But in principle, we could add it to the process to say, yes, there is a reference, there is not a reference. There is a software implementation which Khronos maintains at great expense, and it has a team which manages it. But if you propose a new extension, it is on you to add the code to the reference before you can ship it. That is how we do conformance.
I'm going to throw a brick because you're assuming that somebody who can write a VUID for an extension to the spec can write good software.
I'm not saying it's easy, and I'm not saying it's the same person. I'm saying if you want to add a feature to the spec, you are responsible for finding a way to get it supported in the software implementation.
Give you that out.
So I'm going to cut the conversation here. We can.
I'll do
have a couple of comments.
one last thing. So Swift Shader is definitely 1.2 compliant, and I think it's 1.3 compliant.
It is.
Yeah.
One thing I will mention is Lava Pipe is a Mesa implementation. Unfortunately, we do not have a Mesa representative here at the moment. So that is the other half of this conversation that we are not having.
Hey, I just wanted to ask, so there's been lots of really great presentations on the graphics side of Vulkan, but I'm really interested in the compute side, and we're not seeing much with compute, and I'm just wondering what your thoughts are on the state of compute. Maybe do we need to be doing more? I mean, we might all be sick of hearing about AI, but I'm surprised there isn't really any AI talks in all of Vulkanized. So seems like an opportunity.
So I'll give you my answers real quick because the mic's already in my hand, but I really should shut up and let other people talk. To answer your question, not good and yes. Your questions were, what's the state of compute in Vulkan and do we need to do more? We certainly, I certainly feel like I would like Vulkan to be more of a first-class compute API. I think right now it's a by the way compute API. You can do a great deal with it, but its main advantage right now is that it's very widely deployed compared to other APIs. We would like to do more.
I'll add that from an Android perspective, we're looking at doing more, and not just direct usage of Vulkan, but layered APIs. So I don't know if Brandon's still here. I think I see him over there, but anyway, yeah, we're looking at that with like Web GPU and so forth.
Yeah, so on our side, I mean, we're still in our transition phase from, the prior generation of graphics APIs, but as soon as we get that, more mature in our products, we're definitely looking at moving more and more workloads to compute, things that, might have sit in, application on the application side or C++ side. But I'm also very excited about, the impact of AI and machine learning and how that will change how we do graphics over the next 10 years. So I think that's another reason to look into other options for shading languages and so on. So something that can move fast enough to expose those capabilities. And in our case, not just for one API, we need to target all the APIs. So very interesting open question.
And since you mentioned the machine learning of the AI question, I think I said it earlier. There is a subgroup that is devoted to that. There are a lot of ideas for how to do this, and I don't think there's convergence at this point. You are seeing little things, cooperative matrices here, and but that's just peanuts. Much bigger things are being discussed, but they're far enough out that I can't have really no idea what shape they're going to take.
The only thing I was going to add, just as someone who does compute as a researcher, I guess, is maybe that's the same. Maybe my answer is probably the same that I'm hearing, is that like it's a language problem all the way down. And like as researchers, like we use OpenCL and Transpile to spearhead from there. As someone who has worked with GLSL compute has its limitations. I mean, trying to get some of my lab mates who've only touched CUDA, who are used to being able to have these objects that are available across their host and device implementations, like trying to explain to him, hey, you want to write your application in Vulkan, you got to do everything. I mean, like from what I've seen, it's like a language thing down. And maybe that's like, there's already been a ton of talk about language in the last 40 minutes. But I want to say that like, maybe that's so many talks about language. That's probably the first step down, I think.
So before Vulkan came out, I was using OpenGL and OpenGL ES. So I was very excited to see like one API target both mobile and desktop. But years later, it turns out that you still have to write quite different code paths to hit the optimal sort of path on your target hardware, which makes sense. So my question would be, do you think that like this experiment of like co-evolving both mobile and desktop paths under the same API has been successful, and do you see Vulkan ever splitting into Vulkan and Vulkan ES at any point?
It better not.
I was waiting for you to talk.
So the point about you have to write different Vulkan, or at least your application has to behave slightly differently for a mobile GPU and a desktop GPU. I mean, it's architecturally different hardware, and if we're a low-level API with no secrets, then that's the trade-off there. Mobile GPUs are becoming more and more capable, and I at least would not want to see a Vulkan ES. Quite the opposite. I mean, Samsung has just shipped a handset that has an RDNA 3 GPU in it. Like, I wouldn't want to see that split happen. And equally, we're shipping devices that are Vulkan only, and all the ES is emulated on Vulkan. So yeah, the split is not something that we would want to see.
I think and Tom can slap me on the side of the head, but I think part of the motivation for Vulkan was some high-end game developers wanting to get access, get these abstractions out of the way. I want to get down and close to the hardware. And that really means that it's not just mobile versus desktop. It's really, this GPU versus that GPU, right? If you're doing something for Tom's ARM GPU versus an NVIDIA GPU versus RDNA, whatever, you're going to see differences just because that's what somebody asked for.
So a conversation, we obviously had a lot of conversations on this topic early in the days of Vulkan and tried to decide, what are we going to do? Are we going to add mobile specific or desktop specific features? And what we ended up with, as I remember, to the extent that I still remember anything, is that we wanted there to be a way to write one program that was reasonably performant across desktop and mobile architectures. And we kind of failed, and I think, the noble experiment of subpass and subpass dependencies, that was a case where on the desktop, it's a pure 100% annoyance to have those. And you can't use them and get good performance on desktop. We think with dynamic rendering now moving, it isn't there yet, and it won't be there yet for a while, but with dynamic rendering moving to where it's works equally well on desktop and mobile, and then with a fairly lightweight extension that allows you to capture the bandwidth advantages of subpasses, which are now gone when you have dynamic rendering, we're closer. So it's not, we haven't solved that problem. I mean, you have to say, if you're programming for a high-end Turing or post-Turing GPU and you're trying to get good performance versus, an embedded Intel GPU in a laptop chip, you're going to write different code for them too. So yes, it's not as bad as the problem of moving to mobile chips, but it's still not. You're still making a lot of compromises. So we're trying. You asked, did it succeed? I would say not yet, but it is better than it was with OpenGL and OpenGLES, where we had tons of differences between the APIs, which were completely non-functional. They weren't really because mobile chips couldn't do that stuff. It's just because the ES group didn't bother to put those features in because they didn't see value in them. So there were a lot of, we hope we've gotten rid of the purely annoying differences, and now we're down to the really substantive differences that have a reason for being there. I think that's where we are with that.
So it took about 3 years between DirectX shipping with ray tracing and the Vulkan spec being finalized and shipping. Has there been some sort of retrospective to see if we can avoid the same delay for example, work graphs?
That's interesting. I wish Daniel Koch was here. Well, we got Eric. Eric,
yeah, well,
you address that.
Right. I mean, I'm not involved in things like work graphs right now, but some of that was just there's more different people involved in kind of getting something fully approved and to a Khronos spec, plus that long checklist that Tom was talking about of all the things you need to do. Probably it, if we were really pushing it, probably it could have been faster. But I think it's just the process itself of going through this large group just does slow things down. And also in part where new hardware features don't always get discussed in the more open Khronos groups as early.
Yeah, certainly the case that ray tracing was being discussed directly between, my assumption is, I assume NVIDIA and Microsoft were discussing ray tracing long before anything was even visible to most of the members of the Khronos group. And there's no fixing that.
Yeah.
It's NDA. The question of work graphs is interesting. Of course, that's explicitly experimental in DX as well. There is an experimental extension, but it is AMDX. It is not a Khronos extension at all. It's a really different paradigm, and it is a really miserable fit to a lot of architectures that exist today. And so everybody's looking at it. If it worked great, it would be great. But I think we have to have a lot of feedback basically about implementability from a lot of GPU vendors before we can talk about freezing that.
All right, we have 10 minutes left. I'm going to go over to Hugo, and then I'm going to be pretty judicious in cutting off runaway conversation.
Yeah, so my question is for Ralph. Earlier you said that the Vulkan working group is not really in the business of making the spec easier to target, for students and learners. But are you not? I mean, in the sense that there are things like dynamic rendering, which while they might not be there specifically to make writing Vulkan applications easier, they sure achieve that, as far as I'm concerned. So would you say it's like a non-goal of the Vulkan spec to make it simpler, more reachable, without compromising on the other, design principles?
I should be more careful what I say. So dynamic rendering is a good example of something where there was a real developer pain point and we did some usability work and the API is better for it. And synchronization 2 is another one. So I wouldn't say that usability is a non-goal. No, when I said, we're not going to rewrite the spec, I guess what I was really saying is, can you tell me things outside of changing the API that we could do, like provide better resources or whatever? There is a tension with Vulkan trending lower and lower and usability getting harder. Vulkan does get pulled in multiple directions there, but definitely there have been some places in the API where we've said this is needlessly annoying and it doesn't fit how engines are doing things and maybe we should clean it up. But yeah, I think the short answer is I should be careful about making off-the-cuff remarks.
What's the current state of mesh shading on mobile devices?
Shading, different vendors are doing different things, and we don't. It's actually, I'm looking at Trevor if you want to say anything, or if anybody else does. But
I am not the expert on this.
yeah, I'm not either. But I know that different vendors have sort of different ideas, and some of them are talking, but I'm not sure. I'm not up to date with what they're thinking.
I mean, Tom said earlier that work graphs are a miserable fit for some people's hardware. Mesh shaders in their current form don't work particularly well with tilers. And so if we were going to do mesh shaders for mobile, it probably wouldn't be the EXT mesh shader extension that exists today.
There are ongoing discussions among at least some mobile vendors about what to do about that, because the model's nice and we want to do something in that space. It can't be exactly EXT mesh shaders, which is, by the way, why EXT mesh shaders is not KHR mesh shaders. It's because we can't recommend it as broadly the right way to do this kind of thing.
All right, I have 2 last questions, unless somebody else has something else they want to ask. Okay, this is a softball question. I'm making a rendering engine. Should I be using 1.3 core version? Should I be using Roadmap 2024? Or should I be building my own engine profile?
Are you targeting Android?
Am I targeting Android? Let's say that I am not targeting Android, and we'll start there.
I'm trying not to do all the talking here. Somebody take this microphone away from me. I mean, I'll give you an answer if you want it. But
This question is for you.
all right. How old devices do you want to target? That's kind of it. So Roadmap 2024 is going to be, because it requires new extensions, it's going to be desktop only. And it's going to be desktop discrete only in the short term because people will have to update their drivers. Then eventually it will percolate out into laptop, which I call desktop because I'm a mobile guy, but desktop guys call laptops mobile. It's very confusing. So Roadmap 2024 is out. It's intended to be the future. So you really never targeting that until it's mainstream, by which time it's Android baseline 2022, whatever, right? So yeah, you want to target something that has enough footprint to make you happy in terms of your business goals.
Yeah, if you want reach, I might say take the the LunarG baseline profile and the Android baseline profile and kind of look at the merger of those two. That'll give you really broad reach. If you want to be more selective, go with newer, you can be more selective.
Christoph has tools that will allow you to intersect those two profiles and find the common subset.
Are you saying I should use profiles?
Absolutely. Oh, thank you.
I'll add my perspective. The roadmaps are helping you plan for, what are devices in the future going to be having if you're adding these capabilities to your applications. But for hitting a large set of devices today, you should use some of the baselines, as Ian said, the Android minimum 15, I think it was called. And then we put together some desktop 2024 baselines Christoph did, which was really based on looking at the survey from the GPUinfo.org, what's all the hardware that's out there, and getting a broad base of platforms. Those are profiles. If you're trying to hit volume of devices, that's it. And Christoph wants to say more, so get a mic.
Yes, so the LunarG desktop profile, as I was explaining yesterday, it's based on the Valve survey. So maybe I'm going to throw another question for that. And maybe to extend what Tom was saying, it depends on the business goal. And for that, we need to understand, as an application developer, what's available in the ecosystem. And I think there is a big problem here. It's very difficult. So the approximation we can do these days is with the Valve survey and somewhat with GPUinfo.org. But that doesn't really give us, for many use cases, a good quantification of, especially on mobile, what's really available there and the capability. So what could the ecosystem, what the group could do so that we have a better understanding as application developer on what's available, and to be sure that we can, leverage the feature we want to leverage in our application.
That's a great point. We all know that the GPU info data is wonderful to have, but it's deeply problematic in terms of interpreting it. And, we used to rely, we grasp at straws. We try Steam survey, we try whatever we can get. Google sits on a gold mine of data, as we all know, and the Play Store data is kind of the gold standard for, what you really want to know is, of the people who are buying software in the last 30 days or 90 days, what is the distribution of capabilities across the devices they have? And we don't have, I wonder if you'd kind of like maybe Amazon could solve this problem. I don't know. It's really hard, but you're absolutely right. That's what we need. We don't have it. I don't know how to get it.
We don't have it for desktop, but for Android, with somebody who goes through the appropriate training and so forth, Trevor was able to get access to some data so that he could not just see for different types of devices, but how many of this kind of device and what do they have, and how many of that kind of device that were 28-day actives at the time we did Android baseline profile 2021 and 2022. A lot of work.
No, it's a huge amount of work, but it's priceless for people trying to sell software. They need to know this.
So we're dancing around something here, but my take is that that's a platform problem to talk to their developers and not a Khronos problem. Like Android has that data, they share some of it on their developer pages. The Valve survey tells you something about hardware. Khronos can't be in the business of telling you what percentages of devices exist and what you should target. That's really a platform issue.
But then Windows doesn't participate in Vulkan.
No, but
Linux are it, right? There's lots of Linux.
But the Valve platform survey exists for Windows, right? Like,
okay,
Valve has enough of the market share of games that they cover that one. Linux,
yeah,
I don't know how you do Linux.
All right, moving on, unless we have final comments on this question. Oh, okay, to the last question.
Okay, one question. Are there activities going on to design a kind of a model curriculum to be taught at the university, like for a beginner's course and an advanced course on Vulkan, and what you should teach and which content you would expect to be taught?
We don't have anybody in Khronos with the expertise to do that. I mean, it's deeply interesting. I think it'd be wonderful to have. You are probably in a stronger position. I'm wondering if there are, because really it should be, because you at TU Wien, but there are other people teaching Vulkan course. You really want to get them all together at SIGGRAPH or something and have them talk together and work it out, maybe with some industry people who do hiring to work together on that. Khronos, as I say, is pretty much a bunch of metalheads and spec writers, and I don't know if we, I don't think we would have a whole lot to contribute because we just don't understand the problems that you have with trying to teach.
Thanks.
Oh, that's, yeah, sorry, one more question, everybody. Oh, is it kind of?
I can add. We should chat because what I've had success doing over the past 2 years was integrating web GPU into my parallel programming course because that was a little bit more accessible. And these guys can talk to you because they've been the TAs in the class. But I think it's something that's very needed, and I'm happy to chat more. So,
if you all, can I out you, Tyler? If people don't know Tyler, you should get to know him. He's the guy who discovered this GPU security hole, which you may have heard about recently, where you can leak data through uninitialized local memory in compute shaders. And he's a member, a good friend of the working group. Thank you. And a professor at UC Santa Cruz, right?
Good training would be just really valuable, right? That's why Gabe earlier asked the question about, gee, could you turn your class into into something that everybody could buy and so forth? It's just because it is so needed.
Okay, thank you everyone for your patience on this very long day.